Fuel planning is an important part of the pre-flight planning and, in some cases, part of in-flight replanning. Due to the high cost of fuel, there are commercial pressures on crew to carry the minimum amount of fuel. However, too little fuel will lead to this, and too much fuel may make the aircraft too heavy to get off the ground. This one just made it. The calculation of how much fuel should be carried on an air transport flight is made in accordance with the international agreement laid down in EU Ops 1. It is known as the EASA fuel policy. Under the EASA fuel policy, fuel is considered under the following headings: taxi, trip, reserves, and extra. Reserve fuel is further subdivided into contingency, alternate, final reserve, and additional. We shall consider each heading separately. Extra fuel will be the subject of a later lesson. We shall consider a flight from departure airfield A to destination airfield B with an alternate airfield at C. Taxi fuel is the fuel required to start up, taxi to the runway holding point, and to hold there if necessary. It will also include the fuel required for operating cabin air conditioning and use of the auxiliary power unit, APU. We will now consider trip fuel. First, calculate the fuel required from takeoff, then that required to carry out the instrument departure procedure and to climb to the initial cruising altitude. To this is added the fuel required from top of climb to top of descent, including any step climbs in between. We then add the fuel required from top of descent to the initial approach point, including any standard arrivals procedures that may be required. Then finally, we add the fuel required for the approach and landing. The total of all this is known as the trip fuel. The figures used to calculate the trip fuel are taken from the fuel consumption tables found in the Aircraft Operations Data Manual, ODM, or, for the purposes of the ATPL exam, the CAP 697. Fuel consumption is measured in pounds per hour, kilograms per hour, or gallons per hour. Therefore, by multiplying these figures by the planned time, the result is fuel required in pounds, kilograms, or gallons. Although we have now calculated the fuel required to carry out the planned route, in reality, things may not go according to plan. There are a number of variables in any flight which may require more fuel to be used over and above our planned trip fuel. These may include changes in weather conditions, rerouting, the aircraft using more fuel than expected, and many others. To compensate for these variables, we plan to carry what is known as contingency fuel, in addition to the trip fuel. There are a number of different ways of calculating contingency fuel, as laid down in the EASA fuel policy. For the purposes of the ATPL exam, we add an extra 5% of the trip fuel as contingency fuel. In the event of having to replan in flight, we use 5% of the trip fuel required for the remainder of the flight. If the aircraft is unable to land at its planned destination, it will be necessary for it to fly to the planned alternate airfield. The fuel required for this is known as the alternate fuel. Alternate fuel is the amount required to carry out a missed approach at the planned destination and then fly to the alternate airfield. there is no contingency allowance added to the alternate fuel. Had we arrived at our destination, having used the contingency fuel, carried out a missed approach and flown to the alternate, we would have arrived with dry tanks. This is not acceptable. We therefore plan to land with a minimum amount of fuel still in the tanks. This is known as the final reserve fuel and should never be used, except perhaps in a dire emergency. Final reserve fuel for a turbine-powered aircraft is the fuel required to fly for 30 minutes at 1,500 feet overhead the alternate airfield. And for piston engine aircraft, the fuel required to fly for 45 minutes at endurance speed. Additional fuel may be carried in some circumstances, and these will be discussed in a later lesson. To see how this is included in a computerized flight plan, look at the flight plan on the screen. The plan is for a flight from Gatwick to Frankfurt, with an alternate at Dusseldorf. At the end of line 2, the letters kgs indicate that the units of weight being used are kilograms. Line 4 shows that the fuel required from Echo Golf Kilo Kilo to Echo Delta Delta Foxtrot is 3,091 kilograms. Line 5 shows that the fuel required for a diversion to Dusseldorf is 1,485 kilograms. On line 6, we are given the holding fuel, or final reserve figure, of 1,521 kilograms. Alongside this are the figures 00/30, indicating this is the holding fuel for 30 minutes, as required by a turbine-powered aircraft. Contingency fuel is shown in line 7 as 155 kilograms. This is 5% of the trip fuel shown in line 4. Total fuel required in line 8, which is the sum of all the figures above, is 6,252 kilograms. There is no extra fuel required in line 9, and so the total remains at 6,252 kilograms. Note that the taxi fuel is not included in the flight plan, as this fuel is not intended for use in flight. The decision point procedure is a special case whereby the fuel load may be reduced in order to increase the payload. Consider a flight from Oxford to Faro with a possible en route diversion at Lisbon. The fuel load, excluding the fuel for ground handling, is calculated in the following manner. Trip fuel is from departure to destination via the decision point. In this example, that is from Oxford to Faro via top of descent to Lisbon. Contingency fuel is 5% of the trip fuel from decision point to destination. Alternate fuel and final reserve are calculated in the normal way. Regular fuel checks are carried out by comparing the fuel remaining with the fuel figures shown in the operations flight plan. At the top of descent position for Lisbon, a final check is made. If the fuel remaining is at least the amount required from that point to Faro plus 5%, the aircraft may continue to the destination. If not, a diversion is made to Lisbon to uplift fuel.